Hello everyone, welcome to number 3 lecture 4. So today I'm going to solve not a difficult but a tricky problem based on GCD. GCD stands for greatest common divisor. So the question is we have to find the GCD of given two numbers. The first number is 19 factorial plus 19. Next is 20 factorial plus 19. Now if we simply calculate the number, you'll go nuts here because 19 factorial and 20 factorial are pretty big numbers. So we need to generalize something. So let's start. Now here we want to calculate GCD of these two big numbers. The two big numbers are 19 factorial plus 19 and 20 factorial plus 19. Simply if we calculate the number, their numbers are really big because these two quantities are really huge, and once we calculate this it will be very difficult to see the pattern. So now we want to generalize this. We want to generalize GCD of these two numbers. Then the two numbers are, let's say I'm taking in the terms of n. So we have n factorial plus n, and since it's one more than this previous one, so it's n plus 1 factorial and then plus 19, or you can say n. Now if we start with the small numbers, then we can see the pattern easily. So let's start with n is equal to 2. So GCD, I'm going to calculate GCD of 2 factorial plus 2 and then 3 factorial plus 2. So this number is 4, I can see, and this is 3 factorial is 6 plus 2 is 8. Now GCD of these two numbers will be, I can clearly see it's 4. I'm going to do it for 3 or 4 numbers until I see a pattern here. So let's start with n is equal to 3. So n is equal to 3, we want to calculate GCD of, you can say here 3 factorial plus 3 and then one more, that is 4 factorial plus 3. Now this 3 factorial plus 3 is I think 9, and 4 factorial is 24 plus 3 is 27. You can clearly see the GCD of these two numbers is 9. Now again I'm going to start for n is equal to 4. So GCD, I'm going to calculate for 4 factorial plus 4 and then one more, that is 5 factorial plus 4. Now these two numbers are 4 factorial is 24 plus 4 is 28 and 5 factorial is 120 plus 4 is 124. Now GCD of these two numbers is, I can clearly see here, that is equal to 4, I think, yes. Now I'm going to do it for 5, n is equal to 5, and this will be my last number because out of this 4 I'm going to generalize something, and you will see how am I going to generalize. So for n is equal to 5, it's 5 factorial plus 5 and then one more, that is 6 factorial plus 5. Now this 5 factorial plus 5 is 120 plus 5 is 125, and here 6 factorial is 720 plus 5 is 725. If I calculate the GCD of this will be equal to, if you calculate, it will be equal to 25. Now I'm going to do a generalization here. Now for odd numbers we are finding, let's say for even numbers 4, okay. Next is odd number, that is n is equal to 3. For odd number, when I take n is equal to 3, it will be equal to 3 into 3, can I write here. Similarly for n is equal to 4, I don't see anything here, 4. But for odd number n is equal to 5, again I see one more pattern, that is 25. I can write this as 5 into 5. So when you take n is equal to n odd, answer will be n into n, that is n square. And in this case, we want to calculate GCD of 19 factorial plus 19 and 20 factorial plus 19. In this case, n is equal to 19. So our answer is, for n is equal to odd, answer will be 19 into 19, that is 19 square, and our final answer will be 361. And that'll be all.